Welcome to today's chemistry lesson on chemical bonding. We're going to discover why atoms stick together to form things like water, salt, and metals. This will be super fun. Let's get started. First, what is chemical bonding? Think of atoms as tiny building blocks like Lego pieces. Alone, they are just small bits. But when they join together, they create amazing things like molecules or crystals. A chemical bond is that force which holds the atoms together, like invisible glue that makes atoms stick to form compounds. There are three main types of bonds we will explore today: ionic, covalent, and metallic. Now, the obvious question, why do atoms even bond? Every atom has a center called nucleus with protons and neutrons inside, and tiny particles called electrons zooming around it. Electrons are key for bonding. Atoms want to be stable, like when you feel happy with a full lunchbox. Now, to be stable, atoms need a full outer shell of electrons, usually 8 electrons, like a complete team. This is called the octet rule because oct means 8. Let's dive into the first type, ionic bonding. Ionic bonds happen when one atom gives away an electron to another atom. It's like one atom saying, "Hey, take my toy," and the other saying, "Thanks, now we are friends." This creates charged particles called ions. For example, in table salt, which is sodium chloride, sodium gives one electron to chloride. Electrons have a negative charge. So when sodium loses an electron, it has more protons than negative electrons, making it a positive ion. Chlorine, on the other hand, gains that electron. So it has more negative electrons than the positive protons, becoming a negative ion. Since opposite charges attract like magnets, the positive sodium ion and the negative chloride ion, stick together tightly. This is ionic bond, and it is common between a metal like sodium and a nonmetal like chlorine. Ionic bonds form strong crystals like the salt grains you sprinkle on your food. These crystals can dissolve in water, and when melted, they can conduct electricity because the ions move around. That's why salt water can carry current. Next, let's talk about covalent bonding. In covalent bonds, atoms share electrons instead of giving them away. It's like two friends sharing a chocolate bar. Each gets one piece and both of them are happy. For example, in water, which is H2O, two hydrogen atoms share electron with one oxygen atom. Each hydrogen has one electron and oxygen has 6 in its outer shell, needing two more to be stable. So, each hydrogen shares its electron with oxygen, and oxygen shares one electron back with each hydrogen. This sharing creates pairs of electrons that holds the atom together, forming one water molecule. Covalent bonds usually happen between nonmetals like hydrogen and oxygen. Covalent compounds can be gases like the oxygen you breathe, liquids like water, or solids like sugar in your tea. They don't conduct electricity because they don't form charged ions. That's why a sugar water doesn't carry a current like salt water. Now, let's explore the third type, metallic bonding, which is super cool because it's what makes metals like copper, iron, and gold so special. Imagine a bunch of metal atoms like tiny balls sitting close together in a neat grid, like students lined up in a school assembly. Each metal atom has a few electrons in its outer shell that it does not hold tightly. Instead of keeping these electrons to itself or sharing them with other metal atom, the metal atoms let these electrons roam freely, creating a giant sea of electrons that surrounds on the atoms. It's like everyone in a village tossing their marbles into a shared playground where the marbles roll around and belong to everyone. These free moving electrons are what that make metallic bonds unique. Because the electrons move easily, metals are excellent at conducting electricity. Think of your copper wires in your housing, carrying current because electrons zip through the sea. The electron C also holds the positive metal atoms together tightly, making metal strong and hard to break, like the iron in your maybe bicycle frame. Now let's compare these three bonds. Ionic bonds form between a metal and a non-metal, like sodium chloride, potassium chloride, creating crystals that dissolve in water. Covalent bonds form between non-metals like water, carrying molecules that can be gases, liquids, or solids. Metallic bonds happen between metals like copper, gold, making them shiny and conductive. Each bond gives compounds different properties, which is why salt dissolves but metal don't. Now, why is this important? Chemical bonds are everywhere. The water you drink exists because of covalent bonds. The salt you eat is held together by ionic bonds. The metal in your bicycle is strong because of metallic bonds. Understanding bonds helps us to know why things behave the way they do, like why sugar tastes sweet but salt doesn't. Here's a fun fact to wrap up. Diamonds and pencil lead, called graphite, are both made of carbon atoms, but their covalent bonds are arranged differently. In diamonds, carbon atoms bond in a tight 3D structure, making it super hard. In graphite, carbon atoms bond in flat layers that slide over each other, making it soft enough to write with. Isn't chemistry full of surprises? That's it for today's lesson on chemical bonding. You have learned about ionic, covalent, and metallic bonds and why atoms team up to form compounds. Join us next time on Chemconscious.in to explore more chemistry wonders. Keep curious, and we will see soon.